This is lesson 2.1. It's the greatest common factor. It's on page 31. This is an explore activity. It's best if you try to read the questions and complete this to best of your ability, and then watch the video when you're ready to check your answer, or if you need some hints. Okay, the essential question is, how can you find and use the greatest common factor of two whole numbers? The explore activity is understanding common factors. The greatest common factor of two numbers is the greatest factor shared by those numbers. A florist makes bouquets from 18 roses and 30 tulips. All the bouquets will include both roses and tulips. If all the bouquets are identical, what are the possible bouquets that can be made? Question A says, complete the tables to show the possible ways to divide each type of flower among the bouquets. So the top one is just talking about the roses. And pay attention to the fact that it says that this florist is making the bouquets with 18 roses. So if this florist made one bouquet, it would include all 18 roses. That should make sense. However, if this florist split the bouquets into two, then there would be 9 roses in each bouquet. What about if the florist used 3 bouquets? Well, 18 divided by 3 would be 6. What if the florist made 6 bouquets? It would be 18 divided by 6 would be 3. 18 roses divided by 9 bouquets would be 2 roses in each bouquet. And if there was 18 total roses and the florist made 18 total bouquets, it would be just 1 rose per bouquet. Now the tulips is a little different. The tulips is, there were 30 tulips. So pay attention that the tulips here is going to have some different factors. 30 tulips divided by 1 bouquet would be a total of 30 tulips in each bouquet. If they, however, split it into 2 bouquets, it would be 15 tulips in each bouquet. If you split 30 up 3 ways, it would be 10 tulips in each bouquet. If you split 30 tulips by 5, it would be 6 tulips in each bouquet. So by now, you surely have noticed that the numbers in the table just multiply together. They're factors of the number. They multiply together to become 30. So this would be 5, and this would be 3. This would be 2, and this would be 1. Now there's some follow-up questions that go with what you just did. Question B reads, can the florist make 5 bouquets using all the flowers? Part of me wants to say yes, because check this out. It says 5 bouquets. This right here means 5 bouquets. But can you see 5 bouquets in the other table? You cannot. It says explain. So I think the best answer here would be no, because 18 roses is not divisible by 5 bouquets. You might have written a simpler answer. If you simply wrote 18 is not divisible by 5, that would be good enough too. But the answer to question B is no, because 18 roses is not divisible by 5 bouquets. Question C reads, what are the common factors of 18 and 30, and what do they represent? So here's what I'm going to do to actually answer that question. I'm going to go through, and I'm just going to look at the top line, and I'm going to look at when the top numbers are the same. For example, 1 and 1, that's a common factor. 2 and 2, that's a common factor. 3 and 3, that's a common factor. 5 is not, though, because 5 is not in both lists. 6 and 6, that's a common factor. 10 is not. 15 is not. 9 is not. 18 is not. And 30 is not. So the question reads, what are the common factors of 18 and 30? And they are 1, 2, 3, and 6. And the second question says, what do they represent? Well, in the context of this problem, what do they represent? It means that the florist can make 1 bouquet, or the florist could make 2, or 3, or 6. They represent the possible number. I'm going to say they are the possible number of bouquets. Okay, we are moving on. The next question, D, says, what is the GCF of 18 and 30? GCF stands for greatest common factor, and if you look in both tables, the greatest factor that's in both is 6. 6 is in both tables. So what is the greatest common factor of 18 and 30? 6. And number 1, reflect, says, What if? Suppose the florist has 18 roses and 36 tulips. What is the greatest common factor of the number of roses and tulips, and explain? So the way I want you to see this, I'm going to do a little bit more work than you need to. The way I'd want you to see this would be if there was 36 tulips, this table would look a little different. It would be 1, 2, 3, 4 would go into 36, 5 doesn't, but 6 does, 7 doesn't, 8 doesn't, 9 does, 10 doesn't, 11, 12 does, 13 no, 14 no, 15 no, 16 no, 17 no, 18 does. 18 does because 18 times 2 is 36, and then 36 also does. So that's a little bit messy, but what I want to point out to you is that if there were 36 tulips and if there were 18 roses, which is what this question is asking, I want you to notice that 18 is a factor of both. So let's review the question. Suppose the florist had 18 roses and 36 tulips. What is the greatest common factor of the number of roses and tulips, and explain? And you would say this: 18 is a factor of both 18 and 36. Okay, good job. You have completed page 31.